When we say non-collinear, it is neither on the x nor on the y axis. So this time, so what if the vectors are um, non-collinear? So when we say non-collinear, these are vectors that are inclined or diagonal in nature if we illustrate this vector in a Cartesian plane. So those are non-collinear vectors. Okay, so how to solve non-collinear vectors? Okay, so we have adding non-collinear vectors. So solving for the resultant of the non-collinear vectors. Okay, first is we will use the component method. Okay, first we have to use the component method. After we use the component method, then later we can now apply the Pythagorean theorem and the trigonometric functions or the tangent function. Okay, so first is to draw vectors on the x and y axis or on the Cartesian plane. Next is to determine the x and y components of each vector. Okay, so after you draw the vector on the Cartesian plane, next is to draw its x and y components and determine the x and y component of each vector. So, sir, paano namin makukuha the x and y component? Okay, so we can determine the x and y component using the sine and cosine and tangent function. Okay? So using the trigonometric function, we can determine the x and y components of each vector. Okay, so after you solve for the x and y component, next is to indicate the direction of vectors, if it could be positive or negative. Okay, so we already tackled the sign convention of the on the Cartesian plane, the positive x, the negative x, the positive y, and the negative y. So if we say positive x, so these are vectors from the that is from the origin to the right. So if from origin to the left, so that is negative x. So positive x if it is on the first and the fourth quadrant, negative x if it is on the second and then third quadrant. Okay, so for the y component, okay, and for the y component, y is positive, it is on the first and the second quadrant. And y is negative if it is on the third and the fourth quadrant. So that is to indicate or to determine the direction of vectors if it is positive and negative. Okay, next is to determine the x and y component of our resultant. Okay, so we will use the x and y component of our resultant to solve for the resultant and the angular direction. Okay, so how to identify the x and y component of our resultant? Okay, so we will just simply add all the x components, so which is our r sub x, the x component of our resultant, and the y components, which is the r sub y. So these are the y component of our resultant. Okay, so that is how to solve for the non-collinear vectors. Okay, so let's try to illustrate these 3 or 5 steps. Okay, so let's try to illustrate. Okay, if this is our given vector, which is the vector A, okay, so if this is the vector A, first is let us determine the x and y component of vector A. So from vector A, so this is our x component, which is the rxa or the r sub xa, and the y component, which is the r sub ya, and our angle theta. Okay, so take note, our goal is to make a right triangle. Okay, the goal is to make a right triangle which consists of our vector, which is the hypotenuse, and the x and y component, which is the opposite and the adjacent side of our angle. And for our angle, okay, for our angle, always base your angle on the x-axis. Okay, so always base your angle on the x-axis. So that is how, okay, based on your angle, okay, if your angle is based on the x-axis, then you can be able to identify the x component and the y component. Okay, so let's have an example for clearer instruction. So para mas maintindihan natin, okay, suppose a person walks 65 meters, 25 degrees east of north. So what were his horizontal and vertical component? When we say horizontal component, so these are the or this is the x component, and vertical is the y component. Okay, so let's try to solve the horizontal and vertical components of the person who walks 65 meters, 25 degrees east of north. Okay, first let us illustrate. Okay, so 65 meter, 25 degree east of north. Okay, so since east of north is lying on the in the y-axis, it is based on y-axis. Okay, so since it is, so from north it moves 25 degree to the east. Okay, since it is on the y-axis, okay, first let us transfer the angle that is based on the x-axis. So ililipat natin ang ating angle that is based on the x-axis. So transfer the triangle that is based on the x-axis. Okay, so paano gawin yon? So since north to the east is equal to 90 degrees, so we will subtract 25 degree by 90 degree. That is equal to 65 degree. So 65 degree is on the other side of the 25 degree. So that is the 65 degree. And since it is from east, then moves toward the north. So therefore, it is 65 degree north of east. Then after that, we can now solve for the x and y component using the angle 65 degree north of east. Okay, so this is the x component and the y component of the angle 65 degree north of east. Okay, to solve for x and y component, we will use the sine and cosine function. First, let's use the sine function. Okay, sine theta is equal to opposite over hypotenuse. If the opposite side is r sub y, Therefore, sine 65 degree is equal to r sub y divided by 65 meters. And that is r sub y is equal to sine 65 degree times 65 meters. And that is equal to positive 59 meters. Okay, take note, positive always indicate if it is positive or negative based on the position of your vector based on its quadrant. So since it is on the first quadrant, and so the y component is also positive. Okay, next is for the cosine function, adjacent over hypotenuse. So since the adjacent side is the x component, so therefore, we will use r sub x as our adjacent side and 65 meter as our hypotenuse. So r sub x is equal to cosine 65 degree times 65 meters. So r sub x is now equal to 27 meter. Positive because the x on the first quadrant is also positive. So therefore, the components, the vertical component of our given vector is positive 59 meters and the horizontal component is equal to positive 27 meter. So that is how to identify the components of our vector. So the x and the y component. Okay, so what if, okay, what if we have three given non-collinear vectors? So what if we have three or more non-collinear vectors? Okay, so how can we identify or how can we add these vectors? How to identify the resultant of these vectors? Okay, so what if we will try to solve for the resultant of three non-collinear vectors? Okay, so these are three non-collinear vectors. Okay, for vector A, we have 200 kilometers 60 degree north of east. For vector B, we have 60 kilometers 20 degree west of south. And for vector C, we have 15 kilometers 315 degree. So these are three non-collinear vectors. Okay, so how can we solve for its resultant? Okay, so to solve for its resultant, okay, first is we have to illustrate these three vectors. Okay, so since west of south and 315 degree are on the y components, okay, so first let us um, transfer the angle of vector B and vector C to the x component. Okay, first, for the vector B, so 20 degree west of south. Okay, so to transfer this, we just simply subtract. Okay, sir, paano namin malalaman if it is on the x component or in the y? Paano namin malalaman if the angle is lying on the x-axis or on the y-axis? Okay, you can determine if it is on the x-axis if the direction after the word off is either east or west. If not, okay, if the direction after the word off is south or north, so therefore it is on the y-axis. Okay. For example, for vector V, since it is on the direction after the word off is south, so therefore it is on the y-axis. So to transfer this, we just simply subtract 90 degree by 20 degree and that is equal to 70 degree. So from 70 degree, so since it is on the x-axis starting from the west, then moves downward to the north. Okay, after you subtract the angle to the 90 degree, so just simply baliktarin nyo lang the angle. So instead of west of south, so now it becomes south of west. So from 60 kilometer 20 degree west of south, it is now 60 kilometer 70 degree south of west. Okay. Next is for the vector C. Okay, vector C is 315 degree. Okay, as I have mentioned on the first part of this topic, that our angle should not be greater than or equal to 90 degree. It should always be less than 90 degree. So to make it less than 90 degree, so 315 degree, since it passes through the um, south, so therefore we will subtract the angle that is equal to south, which is 270 degree. Okay, so 315 minus 270 is equal to 45 degree. And since it passes through south, so therefore it is also on the y-axis. So to make its angle based on the x-axis, we just simply subtract 90 degree by 45 degree, and that is equal to 45 degree. So since it is on the x-axis, so starting from the east, then it moves downward to the south, and that is equal now become 15 kilometer 45 degree south of east. And so to illustrate this, okay, so to illustrate this, we have now the first, okay, 200 kilometer, and then the 60 kilometer and the 15 kilometer vectors. So the x and y component, as well as the um, angular direction. Okay. So for the 200 kilometer, so if this is the 200 kilometer vector, okay, so this is the x component, the r sub xa, and the y component, which is the r sub ya. So the angular direction is 60 degree north of east. Next is for the 60 kilometer. If this is the 60 kilometer, we have the x component, r sub xb, and the y component, which is the r sub yb, and the angular direction, which is 70 degree south of west. And then for the vector c, if this is the 15 kilometer, we have our r sub xc, the x component, and the r sub yc, which is the y component, as well as the angle, which is 45 degree south of east. Okay, to solve for its resultant, first is we have to identify the x and y component of our resultant. But how can we solve for the x and y component? By simply adding all the x component, which is the r sub xa, r sub xb, and r sub xc, for the r sub x or the x component of your resultant, and by adding the y components, which are the r sub ya, r sub yb, and r sub yc, for the r sub y, or which is the y component of your resultant. Okay, so first, let's try to solve r sub xa and r sub ya. Okay, solve for r sub xa and r sub ya. To solve this, we will use the sine and cosine function. For sine function, since the opposite is the a, are the r sub y a, so substitute. Okay, so r sub y is equal to sine 60 degree, 200 kilometers. So r sub y is equal to positive 200 kilometers. Okay, positive because the y on the first quadrant is also positive. Okay, next is for the cosine adjacent. Since the adjacent is the x, so r sub x is equal to cosine 60 degree times 200 kilometers, and that is equal to positive 100 kilometers. Positive because x on the first quadrant is also positive. So these are the r sub x a and r sub y a. Okay, next is for the second vector. Okay, for the second vector, sine. Since the sine is the y component, so r sub y is equal to sine 70 degree times 60 kilometers. Okay, so r sub y is equal to negative 60 kilometer. Negative because y on the third quadrant is negative. Okay, next is for the cosine. Since the adjacent is the x or r sub xb, so r sub x is equal to cosine 70 degree times 60 kilometers, and that is equal to 20 kilometers or negative 20 kilometers. Negative because the x on the third quadrant is also negative. So that is for the r sub x b and r sub y b. Okay, next is for the third vector. Okay, for the third vector, sine is equal to opposite over hypotenuse. Since the opposite is the y component, okay, so r sub y is equal to sine 45 degree, 15 kilometer, and that is equal to negative 11 kilometer. Negative because the um, y on the fourth quadrant is also negative. Okay, so that is negative 11 kilometer. Next is for the cosine. So since the adjacent side is r sub x, so r sub x is equal to cosine 45 degree times 15 kilometers, and that is equal to positive 11 kilometer. Positive 11 because the x on the fourth quadrant is also positive. Okay, so after you solve for the components of the three vectors, next is to add all the x components and the y components. Okay, for our r sub x, just simply add all the x components. So for vector A, we have positive 100. For vector B, we have the negative 20. And for vector C, we have the positive 11. If we add these three x components, it is equal to 91 kilometer. And that is the r sub x or the x component of our resultant. Okay, next is for the r sub y. So for r sub ya, we have 200 kilometer. For r sub yb, we have negative 60 kilometer. For r sub yc is negative 11 kilometer. And so if we add these three, r sub y is equal to 129 kilometer. And 129 kilometer is the y component of our vectors. Okay, take note, always put if it is positive or negative, always indicate the sign. Okay, so positive 91 kilometer and positive 129 kilometer. Okay, why? Why do we have to indicate the sign? because we will use this sign to be able to identify if in what quadrant does our angular direction lies. Okay. So gagamitin natin ito na sign para malalaman natin kung nasang quadrant ang ating resultant. Okay. Next, after we add for the x and y component, next is to solve for its resultant using the Pythagorean theorem. Okay, so using Pythagorean theorem, r sub x square plus r sub y square. Okay, so square root of 91 kilometers square plus 129 kilometers square. So if we add 91 kilometers square plus 129 kilometers square, and then square root, if we input this in our calculator, so therefore the answer is 157.8670 and so on. Okay, so since according to our given, the least number of significant figure is 2. So therefore, we round 157.86 up to 2 significant figure, and that is 1, 5, and so on. So 5. So since the next number of 5 is 7, so we round up from 157, it is now become 160 kilometers, and that is the resultant of the three vectors. Okay. Next, after the resultant, we will solve for the angular direction. And for the angular direction, we will use the tangent function. Okay. Take note, in the tangent function, or okay, take note, in the angular direction, okay, using the tangent function, the opposite side is always the y component, and the adjacent side is always the x component. Okay? So in using, okay, take note, I repeat, in using tangent function for your angular direction, the opposite side is always the y component and the adjacent side is always the x component. Sir, bakit? Okay, bakit ito always y is the opposite and x is the adjacent? Okay, so sabi ko kanina, di ba sabi ko kanina, we should always base our angle on the x-axis. So since it is based on the x-axis, so therefore, x component is the adjacent side of our angle because the angle is based on the x-axis. Okay? So therefore, the opposite side is always the r sub y and the adjacent side is always the r sub x. Okay. So next is to substitute. So we have 129 kilometer, which is the r sub y, and 91 kilometer, which is the r sub x. So theta is equal to arctan 129 kilometer divided by 91 kilometer, and that is equal to 55 degree. So we have our angular direction, 55 degree. Okay? So after determining the angle, next is to determine the direction. Okay. So sabi ko kanina, always indicate the sign of your x and y component because we can use that to identify the direction of our angle. So since our r sub x and r sub y are both positive, so since they are both positive, so therefore, they are on the first quadrant because x and y on the first quadrant are both positive. So, if they are on the first quadrant, therefore, starting from the x-axis. So based on the x-axis, if the angle is based on the x-axis, so the x-axis on the first quadrant is the east. So if the x-axis on the first quadrant is east, and then it moves upward to the north. So therefore, the angular direction or the direction of our angle is from east going to the north. So therefore, it is now north of east. And to complete the angular direction, so 55 degree north of east. And so, okay, and so the angular direction, and so our to complete our answer, so the final answer is now the resultant is equal to 160 kilometers, then comma 55 degree north of east. Okay, so that is the resultant of the three given non-collinear vectors. Okay, so that is how to solve the resultant of a given non-collinear vectors. Okay, try to solve this problem. So if the storm moves 5,000 kilometers due east, then shifts course at 40 degrees north of east for 1,500 kilometers. Calculate the storm's resultant displacement. Okay, so if this is, first we have to illustrate, okay, to be able to solve for its resultant. Okay, if this is the storm, then it moves 5,000 kilometers due east. Okay, and then after the 5,000 kilometers due east, it moves 40 degrees north of east. So from east, starting east, then moves forward to the north. Okay, and that is the 1,500 kilometer, 40 degree north of east. Okay, the question is, what is the resultant displacement of the storm? Okay, this is how we illustrate the movement of the storm and the resultant displacement of the storm. Okay, first, before we can solve for the resultant, let us first find the x and y component of our resultant by adding all the x component of vector A and B, and for the y component of our resultant by adding the y and x, the y component of our vector A and our vector B. But to do that, first is kailangan muna nating isolve the x and y component of vector A and vector B. And for vector A, since vector A moves toward the east, so therefore since east is on the x-axis, and so that is our x component. And for the y component, since the vector A is only lying on the x-axis, so it doesn't have a movement on the y-axis, so therefore the y component of our vector A is equal to 0 kilometer. And for vector B, okay, for vector B, okay, for sign, since the opposite is the y component, okay, since the opposite of our angle is the y component, okay, so we will substitute. So sine 40 degree is equal to r sub yb divided by 1,500 kilometer, and that is equal to, okay, so r sub yb is equal to 1,000 kilometer, and for cosine, which is the adjacent of our angle, is the x component, so r sub xb is equal to cosine 40 degree times 1,500 kilometer, and that is equal to 1,000 kilometer north, or positive 1,000 kilometer. Okay. Next, after that, add the vectors for r sub x and r sub y. So for r sub x, the x component of our resultant, just simply add r sub xa and r sub xb, which is 500 kilometer east plus 1,000 kilometer east. Okay. So if 1,000 kilometer east, since they are in um, the same direction, so just simply add. So 500 plus 1,000, that is equal to 1,500. Then follow the direction, which is 1,500 kilometer east. Okay, next is for the r sub y. Okay, r sub ya plus r sub yb, since r sub ya is equal to 0, and r sub yb is equal to 1,000 kilometer north. So that is equal to 1,000 kilometer north. So since we have our x and y components, then we can now solve for our resultant. So r is equal to square root of r sub x square plus r sub y square. So 1,500 square plus 1,000 kilometer square. So if we input this in our calculator, okay, so that is equal to 2,000 kilometers. Okay, so after we solve for our resultant, next is to solve for its angular direction using the tangent theta. Okay, so opposite is the r sub y and the adjacent is the r sub x. So r sub y is 1,000 and r sub x is 1,500, and that is equal to 30 degree. Okay, so as we can see on the illustration, so since it is from the east, then it moves upward to the north. So therefore, the direction is now north of east. And so the final answer is 2,000 kilometers, then comma, 30 degree north of east.